Hello and welcome to MyScience Tutorials. In today's video we are back with a brand new topic, which is Ohm's law. So in today's video we are going to be looking at Ohm's law and the combination of resistors, whether in parallel or in series, and how to solve examples on direct current using Ohm's law. So without wasting you guys your time, let's get started. So what is Ohm's law? Now, according to Ohm's law, okay, the current passing through a conductor, okay, is directly proportional to the applied potential difference. So according to the observation of Ohm's, he discovered that whenever we applied a voltage across let's say a circuit, okay, the voltage is proportional to the current passing through the conductors. Okay, now if you are well into mathematics, you know whenever we have a proportionality sign and we remove the proportionality sign, we tend to introduce a constant. So in this example, in the case of Ohm's law, whenever we remove the proportionality sign, the constant that we introduce over here is called R, which is what? The resistance, okay, which can either be offered by the wire or maybe an external resistor in the circuit. Okay, so so we have V is equal to what? IR, where V is what? The voltage or the EMF in some instances, then the I is the current, and then the R, as I explained earlier on, is the resistance. Okay, so according to Ohm's law, we have the voltage is equal to the multiplication of the current times the resistance. This is what Ohms is telling us. Now, before we can be able to move on to solve problems using the Ohm's law, we need to look at some instances where we have some series of combinations. So assuming we have a resistor, okay, and they are connected in either parallel, okay, or they are connected in series, how do we get the overall what? Total resistance before we use it in the Ohm's law to get either the voltage or the current? So this is really important, and then we need to go through that. So let me get some space over here quickly. All right, so let's look at resistors in series. So resistors in series. Now in series, let's say this is our first resistor, our second resistor, and then our third resistor. Okay, now in series we have R1 resistor 1, resistor 2, resistor 3. Okay, so in series we need to take note of some facts. That is, the current passing through the resistors, okay, in a series, the current is the same. Okay, so the current passing through over here, the I, is equal to the current passing through the resistor 1, is equal to the current passing through the resistor 2, the same as the current passing through the resistor 3. So our I is equal to what? I1 is equal to what? I2, which is also equal to what? I3. Okay, so the same current passes through the resistors in series. Now for the voltage is split over the resistors. Okay, so to get the overall voltage, okay, we tend to add the voltage on the first resistor plus the voltage on the second resistor plus the voltage on the third resistor. Assuming we have 4, 5 resistors, we need to add the separate voltages to get the overall voltage of the resistor, or overall voltage in the circuit. Okay, now if we now know Ohm's law is V is equal to IR, and then we know in series we have the same current passing through and then the same voltage passing through, what then do we do? Now let's look at how we can find the resistors, okay, how to get a total resistor using these two assumptions. So using assumption 2, okay, or using equation 2 over here, okay, let me use this side. We have V is equal to what? V1 plus what? V2 plus what? V3. And we know from Ohm's law, okay, we know from Ohm's law that V is equal to what? IR, which we have over here. Okay, so we have IR is equal to what? I1 R1 plus I2 R2 plus I3 R3. But from equation 1, okay, we know that what I is equal to what I1 is equal to what I2 is equal to what I3. Okay, so in place of I1, I2, I3, we can use I for all of them. So we have IR is equal to what IR1 plus IR2 plus IR3. But then we have the same I all out, so we can factorize the I out, and then we have what R1 plus R2 plus R3. Okay, but then again we can see that the I over here, which is the current over here, is the same as the current passing through over here. Okay, so they are both the same, so they can cancel out, or we divide both sides by the what, the I. So we will be having the total resistance, which is R, to be equal to what R1 plus R2 plus R3. So whenever you have a circuit and then you have your resistors in series, the overall resistance, okay, of the resistors you have is the sum of the individual resistance of the resistors. Okay, so your R will be what, or your R total will be equal to what R1 plus R2 plus R3. So this formula is very, very important, so let's take note of it. It will come in handy when we are solving problems on Ohm's law, on a circuit using Ohm's law. So let's have a look at the second scenario when we have the resistors connected in parallel. Okay, oops, let me quickly get rid of everything here. Okay, so whenever we have resistors in parallel, okay, which means we have something like this. One resistor is over here, then we have another one in the middle, and we have the final one over here, all connected, and then we have our current flowing through. Now in parallel, okay, what happens is that the current flowing through the circuit, okay, is split over the resistance, the resistors we have over here. Okay, so the current is not the same current that flows through. The current that flows through resistor 1 over here, R1, is different from the current that passes through resistor 2 and then resistor 3. Okay, so to get the overall current that passes through all of them, okay, which is, let me use IT as the total current. Okay, we add the first current that passes through the resistor 1 plus the current that passes through the resistor 2 and then the current that passes through resistor 3. Now the second assumption we can get from the parallel connection is the fact that the voltage applied through the circuit, okay, the voltage is the same across the resistors. Okay, so the overall voltage is the same as the voltage that passes through the resistor 1. It's also equal to the same voltage that passes through resistor 2, and then the same voltage passes through resistor 3. So this is our equation 2. Now if this is the case, then we can now derive an expression for how to get the total resistance of the resistors we have in the circuit if we have them connected in parallel. So let's use equation 1. So we have our I total, which is the total current, to be I1 plus I2 plus I3. Now this is beautiful. From Ohm's law, we know V is equal to IR. So if we make I the subject over here, okay, our I will be equal to what? Voltage over resistance. Okay, so it means over here, instead of having IT, we have VT, the total voltage, over what? The total resistance, RT, is equal to what? V over R1, which is V1, plus V2 over R2 plus V3 over R3. Now if this is the case, okay, and then we know that from the second assumption we have over here, okay, the total voltage, okay, V total, but V total is equal to what? V1, which is equal to V2, which is equal to what? V3. So in place of V1, V2, V3, we can put V total over there. So we have what? V total over what? RT is equal to what? V total over R1 plus V total over R2 plus what? V total over what? R3. Now we factorize out the V total, okay? So we will have V total into bracket 1 over R total, okay? This is the same as what we have over here, is equal to what? V total into bracket 1 over what? R1 plus 1 over R2 plus 1 over R3. Okay, so from here we can cancel out the V totals that we have, and then we get to realize that the overall resistance, okay, when we have the resistors connected in parallel, is given by what? 1 over RT, which is the total resistance, is equal to 1 over the sum, the inverse of the sum of the resistors, so 1 over R1 plus 1 over R2 plus 1 over R3. So this is how we use Ohm's law and this simple assumptions that we made over here to derive an expression for the total resistance in a circuit. Okay, so let's move on. So let's also take note of this, and then let's take note of how to get the total resistance in case we have the resistors connected in series. Now let's look at something else. We have something we call internal resistance. Internal resistance. Now what is internal resistance? Now internal resistance is the resistance offered by a cell, okay, within a circuit. Okay, so whenever we have a cell in a circuit, sometimes they tend to offer some resistance to the flow of current through the circuit. Okay, so this internal resistance is represented with small r. Okay, and then let's look at how we derive an expression for that. So whenever we have an internal resistance, okay, then the total resistance of that particular circuit becomes what? The R total becomes what? The resistor, in case we have a resistor over there, the resistance of that resistor plus the internal resistance of the cell. Okay, so this is what we get as the total. Now mind you, if you have the resistors in series or in parallel, you need to, like, the R over here will not just be 1 R. If it is in series, you add the R's, R1 plus R2 plus R3 before you add the internal resistance. If it is in parallel, you add 1 over R1 plus 1 over R2 plus 1 over R3 before you add your internal resistance. Okay, so from here the EMF or the voltage, the EMF, okay, which is represented with E, or we can say the voltage. Okay, so normally with internal resistance they tend to say EMF instead of voltage. So the EMF is given by, just like Ohm's law, is IR. Okay, now R total, now the EMF is equal to, now the total resistance over here, okay, is equal to what? R plus small r. Okay, so we have the current into bracket R plus small r. So our EMF is equal to what? Current times R plus I small r. Now we know from Ohm's law that V is equal to IR. Okay, so the EMF, okay, the EMF is equal to what? The voltage, okay, plus what? IR. Okay, now let's look at something interesting. So the relationship between the EMF of a cell and then the voltage of the cell is the fact that EMF of a cell is equal to what? V plus IR. Now what is this IR? The I and then the small r. The I and then the small r is called what? The lost voltage. Okay, so whenever we have current multiplied by the internal resistance offered by a cell, the whatever we get is called the lost voltage. Okay, so the EMF of a cell is equal to what? The voltage plus the lost voltage. Okay, so that we get a voltage plus the lost voltage. So this is the relationship between EMF of a cell, the voltage, and then the lost voltage. Okay, so in case you are asked to find the lost voltage, okay, all you need to do is to get the current that is flowing through the circuit, and then you multiply it with what? The internal resistance, and then you get your loss voltage. Now if we all understood everything that I've explained so far, then let's have a look at some few examples to enhance our understanding of the concept Ohm's law. So yeah, so let's look at example number 1. So in example number 1, let's write solution over here. Okay, so we have a cell offering a voltage of 6 volts, and then it has an internal resistance of 0.5 ohms. Then we have an external resistor which is giving us 0.2 ohms over here. Okay, and then we have the current flowing in this direction. So from here straight away we can see the EMF over here. The EMF, this is the EMF offered by the cell. The EMF is equal to 6 volts. Okay, so the EMF, we know EMF is equal to what? Current, okay, times into brackets R, which is the total resistance of the cell, plus the small r. Okay, now the EMF in this example is 6 volts, so we write 6 is equal to, we don't know the current, that is what we are looking for, so we have I. And then the resistance offered by this resistor is 2.5 ohms, so it's 2.5, plus the internal resistance of the cell is what? 0.5 ohms. Okay, so we have 6 is equal to, now this is what? 3. So we divide both sides by 3, then we get our current to be what? 2 amperes. Okay, so in this example the current flowing through this circuit is what? 2 amperes. Beautiful. Let's have a look at the second example. So let me write here solution. Now in the second example we have 2 resistors and they are connected in series. Okay, so let's look at all that we have. We have our voltage source is equal to 2 volts, and then we have our current passing through, but then we don't know our current. We know the resistance of the 2 resistors we have over here. So we know V from Ohm's law, V is equal to IR. Okay, now the resistor we have over here, they are connected in series, so the R total, okay, will be equal to what? The sum of the first resistor plus the resistance of the second resistor. Okay, so it will be 1 plus 1, which is equal to what? 2 ohms. Okay, now from here we know that 2 volts, okay, is equal to what? The current we don't know, times what? 2 ohms, which is the resistance we have over here. Okay, so we divide all by 2. Okay, this is I. Okay, so we get 1. Okay, so our current in this example is what? 1 ampere. Okay, so let's have a look at the third example over here. Okay, so the third example we are looking at the EMF. Okay, is giving us 10 volts. We don't know the current. We have 2 resistors connected in parallel, then we have an internal resistance offered by the cell. Okay, so in this example we have the solution. Okay, we know the total resistance, okay, in the cell will be what? The total resistance of the resistors we have over here plus the internal resistor. Okay, the resistance offered by internal the cell. Okay, so this one, they are connected in what? Parallel. Okay, so the R over here will be what? 1 over 2 plus 1 over 4, and this is giving us, let me quickly punch that. So we have 1 over 2 plus 1 over 4, and this is giving us what? 3 over 4. So our resistance over here is 3 over 4. That is for just these two. Okay, so the R total in this example is what? 3 over 4 plus 0.5. Okay, and this will give us plus 0.5 will give us 5 over 4, or 1.25 ohms. Okay, so this is the total resistance that is flowing through this whole circuit. Okay, so from here we know that what? Our voltage, or the EMF, V, is equal to IR. So I is equal to what? Voltage over resistance, which in this example will be what? 10 divided by 1.25, and this will give us 10 divided by 1.25. So this is equal to what? 8 amperes. Okay, so the current passing through this whole circuit is what? 8 amperes. Okay, so this is how we solve examples of direct current questions using Ohm's law, and then even combining the internal resistance of a cell. Okay, so thank you guys very much for watching, and then I'll see you in the next video. If you are new to my science tutorials, kindly consider subscribing as we post daily videos on physics, chemistry, biology, and mathematics. Okay, so thanks so much for subscribing and liking our videos, and then I'll see you in the next one. Bye bye.